Hey guys, welcome to our channel Coders Arcade. This is Ashank David, and in today's video, we are going to talk about priority queues. This is the program which I have already written for you to explain, and we are gonna understand priority queue implementation today with the help of an array. Now, this is gonna be just a peek video where I am just gonna just show you about how it works. More detailed video will come very soon on our channel, where we will be explaining you everything about priority queues. So stay tuned for that. Right now, for this video, I've just because there were a lot of comments coming up for priority queues, so I created this video. So let's start. So before I start with this video, I would like to request you people to please like, share, and subscribe to our channel, and don't forget to press the bell icon so that you won't miss any future updates. Now let's get right into the topic. So first of all, we need to understand exactly what is priority queue. So the difference between a priority queue and a regular queue is that in a regular queue, queue is open from both the sides, and that's a data structure. Well, elements are stored in that queue, and whichever element is added first gets deleted first. That's a normal queue. But in priority queue, the queue is the same, but then the elements which are actually getting inside it, they'll get inside normally, like with the normal enqueue function. But when we'll pop the elements there, they will be popped based on their priority. So yes, when we enqueue or we push the elements into the priority queue, we take two things, that is the value and their priority. So priority is attached to every element inside priority queue. And for this reason, we call it as priority queue, where every element will have its own priority, and based on their priorities, elements' priorities, they'll get popped up from the priority queue. Well, this is how it is done. So let's see the quick implementation which I have already written for you. More detailed video, I'm going to create another separate video where I'm going to explain you about priority queues in a much more better way. So let's start. So here we have created a structure where I have just created a structure called as item, and inside this we have taken two things, so that is value and priority. Because in the queue, every element will contain its priority also. So we need a structure, or maybe you can create a class and later on you can instantiate the object. Well, structure is straightforward, easy method of doing this. So created a structure where it allows us to create a structure variable, which allows us to put both value and the priority with it. So with that, I've created a array of type structure, and this array is going to hold like I've given a static size here. Well, you could have used vectors also in this case, so it will be dynamically changing accordingly and it will take less space, but because I wanted to make this video as simple as possible, I have taken the fixed size, and today we are going to work with this. The size variable which you see here is set to -1. This tells us that right now the priority queue is empty and there is no element inside it. When we'll put the elements inside it, when we'll write the enqueue function, at that time we'll increase the size. So as in the enqueue function, you can see there are two values that are getting added. There are two parameters, and the first parameter is the value and its priority. So we're going to take it as the arguments, and size plus plus first will increase the size, and then on that particular index we'll put the value and its priority, as simple as that. This is the push function, and then this is a peak function. Why we want to create a peak function? Because later on in the dequeue, in the pop function, we will pop the element based on its higher priority first, and peak function is the function which will allow us to get the highest priority of the element with the highest priority. So for that reason, I am using peak. Later on, this peak function will be called inside this dequeue. So after this, we will create a function, we'll create a variable called as highest priority, in which we are going to set the minimum most value so that later on it can be filled up with the maximum value later on. And we have created an index variable, and where the index is set to -1 as of for now. Then we will check the element with the highest priorities. For that, I'm just iterating over the array, and we are checking if the priority is same or not. If the priority is same, we'll choose the element with the highest value. So for that, we checked if the priority right now in that particular element, while we are iterating its priority and the index is greater than -1. That means the index, the queue is not empty. First thing, the queue is not empty, and the priority is present, and the priority, the index value is lesser than the element value. In that case, what happens is the priority, highest priority is set to that particular element. So that priority will be taken up and the highest priority will be set it up into this. And the index will update with I. If the highest priority is lesser than the priority of that particular element which you're talking about on where when it is getting iterated, the highest priority will become that particular priority. And then the index will be updated. I hope so that you have understood this conditional statement here. So this is gonna be priority. If we'll check if the priority is same, we'll choose the element with the highest value, and that's the highest value. Then later on, because this peak function was having the return type as int, we were just returning the integer type, so that we were just returning the index, which we were set at the last. Once we do that, now we created a dequeue function where we just called and we got the highest priority element first using this peak function into this index variable, and then we shifted the elements one before the position of the element with the highest priority is found. So what this will do is it will bring it to the side and we will just decrement the size. So what we did is we just we just in iterated over the array, and at that particular element we shifted it by right, and this way we'll be able to decrease the size, and later on once we decrease the size, that will get dequeued or popped. So the idea here is get the highest priority, shift that highest priority, and then you pop or do size minus minus. This is our main function, and inside this we just did the enqueue. Okay, so now you see, observe that there are two variables with two values with the same priority. In that case, whatever is in the first element will get dequeued. So in this case, we'll find the index. In that case, what happens is then whenever there are two values, then with the same thing, we will take the value in this case. So first, this element will be popped up. So we'll store the element on the top by just saying we'll just check with the help of peak function, which is the highest element. Right now, the highest element will be the 16. And then we just printed that particular value and we just dequeued it. So as soon as we dequeue it, we'll just check if which is the top element again, and we dequeue it again. And again, we repeated the same process. And you see, when I run this program, you see first the element is 16, which gets dequeued, and then 14, and then 12. This way, our element is dequeued. So this is how your priority queues works. And now only 10 is remaining in the queue. Well, I hope so that you have understood this very well, the explanation part. Now, more detailed video will come very soon on priority queues in our data structure playlist. And yep, I hope that you have understood this really well. If you like this video and understood the concept very well, tell us in the comment section below. And if you have any doubts, you can ask us in the comment section as well. Uh, don't forget to like, share, and subscribe to our channel, guys. And please share this video to your friends and families and whoever is learning data structures with us. So that's all for this video, guys. I hope this video helped you in a quick manner, and I'll see you guys in the next one. Well, more on this, and very soon create a more detailed video on Hyper on priority queues where I'll explain you on the board, and we'll do the most of it. Well, that's it for this video, guys. Thanks for watching. I'll see you guys in the next one. Peace.